One of the important properties of gases that we're going to take some time talking about in this video is pressure. And pressure is a force that gases, and anything, this also applies both to liquids and solids, can exert pressure too, but is in particular an important property of gases, and is really tied to how they behave and what they do. And so we're going to take some time detailing this. So pressure comes from, if we think about sort of a square on the ground or whatever, there's a bunch of gas above it. And I'm drawing only a few particles, but it's really like, billions and billions and billions of particles. These particles are going to collide and push on this square of ground, or this could be a square of your skin or something like that. But this has some particular area, and all this gas pushing on this area will exert a force. And so we define pressure to be how much force is exerted for a given area of an object, whether that be the ground, whether that be your skin. There's a constant pressure that's always on you, on your skin. You just don't notice it because you live in it all the time. You do notice it when it changes and you go either up in an airplane and the pressure decreases and you feel it in your ears, or if you go underwater and you feel that pressure of much more water than we have usually of air pushing on us, then you notice the difference. We're just sort of used to this constant pressure that we call atmospheric pressure from the atmosphere around us. And so that is the fundamental idea of pressure, is that it's a force exerted over an area. And so if we write this in SI units, just to talk about units, the SI unit for force is a Newton, and the SI unit for area is a square meter. And so this is 1 unit of pressure is newtons per square meters. We give this its own name. This is called a Pascal. And at least as somebody who works in atmospheric stuff, we don't use this unit very much because Pascal is a very small unit of pressure relative to sort of what we're usually measuring. So another type of another unit that's used for pressure is what's called millimeters of mercury. And let's explain where this unit comes from. So to measure pressures, back a long time ago, this is not used so much anymore. I just want to make this picture bigger here. We could use a device like this. This is called a manometer. A barometer. There's different kinds of pressure measurement devices. So this was developed, I believe this one, back in the 1700s. It's somewhere here in your textbook, by Torricelli, 1600s, so even older than that. And this was sort of one of the first pressure measurement devices called a barometer. And the idea is you take a tube of glass and you fill it with mercury. Now, why use mercury? Mercury is very dense, so you don't need as much of it. It's a liquid at room temperature. We don't use it anymore because it's also toxic. But at the time, they didn't know that. And so mercury was used for a lot of things, including thermometers. You probably maybe have heard of a mercury thermometer or things like that. But anyway, this is how this was originally done, and so this is how the unit sort of worked out. So if you take your tube of glass, you fill it all up with mercury, which is a nice silvery metal. You then have a pool of mercury. You tip your mercury tube upside down into that pool without letting any gas get in. Right? So there's going to be, you're going to get something like this. There'll be a space up here that's vacuum. There's no gas up here. Of course, it's not a complete vacuum, but it's a very, very, very little gas in here. And there's going to be pressure pushing on the rest of the mercury down in the pool here. So that's what's being shown by this blue arrow here. We have the atmospheric pressure. Now this whole thing is going to be at equilibrium. And so there's also needs to be an equal pressure being exerted by the mercury inside of our tube. And so those will balance out. Those pressures will be equal to each other. And so the way we can measure how much force the column of mercury, the air is pushing down on, is to see what's the height of the mercury that it will support. So the height of this column of mercury is how we determine the atmospheric pressure. It's good because these are equal to each other. And so what you would do is you would measure how many millimeters of mercury the atmospheric pressure could support. So this is a unit of pressure as well, millimeters of mercury, mmHg. And that's literally from just taking a device like this, using a ruler and measuring from the bottom, from the mercury pool up to the top of that height of that mercury column, and that is a measurement of pressure. And then that height will go up and down as the pressure being pushed, that the air is pushing on the pool of mercury, changes. Now, this device was originally developed by a scientist with the last name of Torricelli. I believe he was Italian. And so this unit is also known as the torr in honor of Torricelli. So millimeters mercury torr. And this relates to another unit of pressure that's very common, which is the atmosphere. We write that as 1 atm. And this is just equal to the average atmospheric pressure on Earth. So for the gas around you that's just pushing on everything around us all the time, that pressure is defined to be 1 atmosphere. Now, of course, locally that'll vary a little bit depending on the weather, but this is the average at sea level. Of course, that will decrease as you go up into the mountains and things like that. And to relate these two different pressure units here, 1 atmosphere is equal to 760 torr. All right, so this has been measured, and this is a definition. So millimeters of mercury is defined relative to this barometer that we have here, and then 1 atmosphere has been measured to be 760 torr, and we set those as the exact values. Okay, so that's an introduction to pressure units. Again, the Pascal, which we have up above, is not as commonly used, but it is still a unit that's also in use. One other unit that's commonly used that's related to pascals, actually, that you may see. I would focus mostly on these ones, but another one that's very common and very close to an atmosphere is what's called 1 bar, which 1 bar and 1 atmosphere are almost the same. The actual conversion between them is that, I always forget it. Here it is, 1 atmosphere is equal to 1.01325 bar. So an atmosphere is slightly bigger than a bar in terms of pressure. And 1 bar is exactly equal to 10 to the 5th pascals. So that's how a bar is, and this relates all these different pressure measurements. For our purposes, that's just more for your information. We're mostly going to be using either atmospheres or torr for our pressure measurements in this class. Okay, so that's an introduction to pressure. Now, again, a reminder with all of this is that what causes pressure is collisions, right? It's coming back to the picture that I drew up at the top. What's happening here is we have gas particles colliding with the walls of whatever they're in. So it may be the ground or your skin, maybe the wall, like if it's in a glass bulb, it'll be the sides of the bulb. It's that force that's pushing against those. So as that force, as either the number of collisions increases or the strength of those collisions increases, that will affect the pressure. And so that's what's going to drive a lot of the properties that involve pressure in terms of gases. Your book goes through a couple more things in terms of thinking about how do you actually measure pressure. We're not going to go into that in great detail, but it all comes back to this idea of balancing out two different forces pushing on things. So usually you have some reference point that you can compare to be able to measure the pressure. All right, so that concludes this video on pressure. In the next video, we're going to start talking about some of the laws that govern gas behavior that were discovered over the course of many actually centuries, a couple of centuries in the 16, 17, and 1800s. So see you in the next video.